Okay, I'm going to go ahead and continue our discussion on encryption, and I'm going to introduce the idea of private key encryption through an example. So private key encryption is covered in the Snyder textbook, and really what we're looking at doing here is coming up with an algorithm to convert from clear text to ciphertext. All right, an idea behind a private key is that we have a private key, which means myself, who is the sender, and the recipient have a copy of that key, and nobody else does, and nobody knows what that key is. And that key that we're going to use is going to just be a random number. So we might have some random number that is used to decrypt this message, and on my end I'll use that random key to encrypt it. Right? So the private key we're going to choose, and again, it doesn't have to be any particular number. There's no significance to the number 4, which I'm going to use, other than it's just randomly select it. Now we would probably choose a much larger number than 4. 4 makes a pretty simple code to break, but we'll use 4. All right. The other thing that we'll kind of agree upon is that we're going to use blocks of 2 characters. All right. We could use blocks in our message of 4 characters or 8 characters or 128 character blocks, and then encrypt them with the private key, whatever that is. So those are kind of the two different values we have that we'll have to work with in our private key encryption scheme. All right. So I shared this private key. We've agreed upon our communication. Nobody else knows it except for us. So first step, I'm going to convert our message to Ascii. And of course, we're using a computer system. It's already in Ascii. But I'm going to, for my example, just use decimal numbers because they're easier for me as a human being to do computations with versus binary or hexadecimal. All right, so I'll take my message, convert it to Ascii, group the characters into blocks of 2. All right, so 2 characters per block. Then I'm going to multiply each block by my cipher key, and I'll send it across the line. All right, on the other side, my recipient will need to go ahead and take that message and divide by the cipher key, and then group it back into, or ungroup it into blocks of 2, and then we can decode it. All right, so that's our example. Let me start with, well, let's pick DOG. That's an easy one. So I want to send the secret message dog to my recipient who has this encryption. All right, so we convert it to Ascii. You can do this. Look at, find your Ascii code in your textbook. 68 is D, 79 is O, 71 is G. Okay? All right, step 2, group in blocks of 2 characters. All right, so we'd have 6879, and then we have 71. Oh, wait a minute, we don't have enough characters here. We have an odd number, so let's just pad this with a blank space. Okay? 32 is a blank space. So I'll pad this with a 32. All right? Let's go down to step 3, multiply by the cipher key. What's our secret key that we decided on? What was 4? So 6879 times 4, and 7132 times 4. We go ahead and perform that calculation. 6879 times 4 is 27,516. And then 7132 times 4 is 28,528. Okay, so we send these what look like meaningless numbers, unless you have a private key, okay, across the public network. And on the other end, my recipient says, oh, I got a message here. Let's decrypt the message. So I'll take that message, and I've received 27,516, and I will use the inverse of whatever the encryption is. So we're using multiplication. Well, the inverse of that's going to be division. I'll do the same thing with 28,528. Divide that by 4. Okay. And of course, that comes out to 6879, 7132. And then I ungroup these blocks. So I got a block of character 68 in the first block, and 79 in that first block, and I have a character 71 and 32. And I go back to my Ascii character set, and I encode or decode it, and that's going to be capital D, capital O, capital G with the space. Okay, so there's a nice, easy, simple example of how we do encryption using private keys.